In this first video, I want to share some of the information from a chart that is posted in the classroom on the door going past the cupboards where we store the safety glasses. There is this chart posted on the wall, and you may have walked by it many times going to the machines but never really paid attention. This important chart shows a lot of useful information for concepts that you would use if we were in the classroom. For the first video, I want to concentrate on what's in the red box, and then later on we'll go through what's in the blue box. In the red box, which I highlighted, there are a whole bunch of numbers. And just to make it easier, I switched it to a PDF so I could zoom in. And essentially, there are five pieces of information in this chart. The easiest way to start is I'm going to scroll down and start at something that's familiar. And it's right here. In this chart, they're showing you all these different sizes for drill bits. And they give it in two pieces of information. The common size, and in this case it's a 1/2 inch drill bit, and on the right side of it they give you the decimal value in thousandths of an inch that it would be. And I chose this one because I think most people have math skills strong enough to say a 1/2 inch is 0.5. But in our case, because we're doing thousandths of an inch in the imperial system, it's decimal 500. This chart I don't really like in a sense because it actually goes one more decimal. That's 10 thousandths of an inch. And normally we're only interested in going to 3 decimal places. Okay, it's to the thousandths of an inch. We're not so much interested in that last decimal. So if you had something that was a 1/2 inch, the decimal equivalent would be 0.500. Half of that, there's a 1/4 inch. And 1/4 inch is 250. If you scroll down even more, all the way to the end, there's 1 inch, and it's 1.00. So you've seen all that before. If you notice, you will see a whole bunch of fractions in red. And all of these red fractions represent the sizes of different drill bits. And I'm going to start with this set right here, because this is a set of drill bits that I found as a picture. And this is probably, if any of you have drill bits at home in your shop or in your garage or in a toolbox or something, you probably have this kind of a set, typically. And you can sort of zoom in and you see all of the fraction sizes. There's a 1/4 inch drill bit. If you go smaller, 3/16. You go a bit smaller, there's 1/8. For you math people, that's 2/16, 1/8. Go all the way down, there's 1/16. But there's also these other fractions. 64s, 30 seconds, 5/30 seconds, 13/64s, 9/32s. And it goes up, and they get bigger on the next row in the back. And then the biggest ones all the way up, you can just see it sneaked in here, 1/2 inch. So each of the drill bits has a specific diameter of hole it will make when you use it to drill a hole. So for example, 15/64. How do I do that? Well, I can go back to the chart and I can look up, there's 13/64. If I keep going, there it is, 15/64, 234 thousandths of an inch. That's that size. Any other one of these red fractions all have some decimal equivalency. So if you have a certain drill bit and you're wondering, well, what size of hole is that really? You can go to this chart and look up that size. So that's the first kind of drill bits that I wanted to show, fraction ones. And this chart is very good for that. If you look in the red chart, in the red box, of the chart, you will see all of the different fractional sizes of drill bits that are possible. Now, there are other kinds of drill bits left over from this crazy imperial ruler measurement system. There is another kind of drill bit set. They're called number drill bits, and I looked them up. This was the best picture I could find, but there are other ones. If you look on the set, you will see their numbers of sizes. They don't actually tell you the fractional size. And I've never really understood why the British imperial system has this, but it is what it is. Now, in this case, it's a numbered drill bit size. The highest number is a 60. You can just see that little drill bit. Number 60 is a really small drill bit, and it goes backwards across the rows all the way to this last one in the corner. It's a number 1 drill bit. What sizes are they? Well, the chart will tell you that. You can see them. I gotta find where it starts. There it is. A number 1 drill bit has a diameter of 228. Number 2, 221. Number 3, 213. It's a bit of a crazy system. As the number gets bigger, the diameter gets smaller. But you can see it's going there, and then it comes down. There's 30, 34, 38, and it goes all the way to a number 60. And I'm stopping at 60 because that's the size in this drill bit set, just because I know we have that same set in the school classroom. It goes from number 1 to number 60. The number 60 drill bit is actually pretty small. It's only 40 thousandths of an inch, which is maybe 8-9 sheets of paper thick. It's not a very big drill bit. It's almost the kind that maybe your dentist would use if you ever see them. Now, what's crazier is, look, 61, 62 goes all the way down to the smallest drill bit. It's a number 80 drill bit. And to be honest, I've never seen a number 80 drill bit. It's got to be really small. It probably looks smaller than one of those pencil leads you see in those mechanical pencils. 13 thousandths of an inch is about the diameter of 3 sheets of paper, 3 sheets of paper probably. So it's pretty small. But again, the number drill bit system is something from the imperial system. I'm not going to try to explain it. You can look it up if you're really interested. But this chart will give you that information in all of those numbers. The third one, just to be even crazier, fractional ones, okay, that makes sense. Number system, okay, British thing. Well, they also have what are called letter drills. And I found a picture of that set, and I do have a set of these in the classroom, but it's, again, a funny British imperial measurement system, which I'm probably some story behind it, some history. But it's a letter system that goes from A, and it goes all the way up, if you can kind of see in the picture, a Z, and that's the largest one. A is the smallest, Z is the largest. What does it mean? Well, if you go to the chart, there's a letter A, 234 thousandths of an inch. B is a bit bigger, 238. C, and on it goes. And then eventually you get to Z, 413 thousandths of an inch. As you go bigger than Z, you don't see it anymore. There's no more letters. So the letter drill set starts from A, goes to Z. 26 letters, 26 drill bits in that set. Numbers, they're smaller. They go backwards in a sense. So the number 1 drill bit goes all the way down to the number 80 drill bit. And the sizes are all in the chart. At the top of the chart, they talk about this. Fractional. The number system they call wire gauge, and there is a history behind that. There is an explanation, but I'm not going to get into that. Those are number drills. Letter drills, another British thing. Probably like, I don't know, French verbs. You remember how you have the rules and all the exceptions and all these different things that, yeah, it's just like that, I guess. The last one, not as common in North America, but it is changing. But in parts of Asia and parts of Europe and other places where the metric is quite common, you see the blue letters, blue numbers. So 5 millimeter drill bit is equivalent to 197 thousandths of an inch. A 9 millimeter drill bit would drill a hole 354 thousandths of an inch. So even though I don't have metric drills in the classroom, the chart shows you the equivalency or does the conversion for you in terms of the diameter of the hole in thousandths of an inch. So with the chart, looking in the red box, you can look up the diameter of hole for almost any available drill bit. Okay? Now, going backwards, let's say you're making a project and somehow you need a 263 thousandths of an inch diameter hole. 263. What drill bit do I use? Well, you'd go onto the chart and you start scanning down. You know, like 252, 259, 261. Oh, there it is. A 263. That's what I was needing. Uh-oh. I need a 6.7 millimeter drill bit, but we don't have metric drill bits. So what will I do? Well, if I want 263, then I have to make a judgment call. I can go find the 1764. It's going to be drilling a hole just 2 thousandths of an inch bigger than I want. That's not even the thickness of a human hair. So I might decide, you know what, I can live with that. If you went and found the G drill bit, 261, about half a human hair too small. Is that going to be a problem for my project? Maybe, maybe not. You have to make a decision, but the chart will guide you to make the right choice. Make up another one. 307, let's say. So I go onto the chart, and there they are. An end drill, I have that one, 302. 5/16, 312. If you really, really, really want a 307 thou hole, then you have to go find that drill bit. Now, for most things and most applications, nobody's going to do that. They'll just go find the one that's a bit bigger but pretty darn close, good enough, drill the hole, little bit bigger, nobody's going to notice, depending on what you're trying to do. Okay? So just to recap, you have 4 types of drill bits. The chart that we're looking at can show you the decimal equivalents to 4 decimal places, even though we're not really that worried about it. I'm only really interested in the first 3 decimals, 312 thousandths. It will give me 4 types of drill bits. The most common, fractional ones. The second most common, letter. The third most common will be number ones. We're going to find them again. There's a number drill. And the not so common in North America, at least, are the metric drill bits. Okay? So zooming back out, that chart on the classroom wall is summarized in a couple of sections. The first big section is the red box, and it's really just about the decimal equivalents for the different kinds of drill bits. Okay, I'm going to build on that in the next video, talking about nuts and bolts and hole sizes, because eventually I want to explain the blue side, that blue chart, sorry, the blue box in this chart. Okay, bye for now.